Dear students, this session we are going to study about the Green's theorem. Green's theorem statement. If u, v, dou u by dou y, dou v by dou x are continuous and one-valued function in the region R enclosed by the curve C, then single integral over C u dx plus v dy equal to double integral over R dou v by dou x minus dou u by dou y into dx dy, okay, is a mathematical form of Green's theorem, right? So here u v are functions in x and y, dou u by dou y and dou v by dou x are partial derivatives, right? So here there is no vector functions, so here we have only scalar functions, right? Simply functions. Okay, so here single integral over C u dx plus v dy is equal to double integral over R. C is a closed curve, right? Closed curve. Okay, what is R? R is the region covered by the curve, closed curve C. Okay, so here important notice Green's theorem is a special case of Stokes theorem. One more point is Green's theorem is applicable only to the plane, not for a space. Okay, right? Okay, so here in this theorem, Green's theorem is applied for xy plane, right? So here we have two axes x and y, right? Now we are going to see problems on Green's theorem. First problem, verify Green's theorem in the plane xy for integral over c 3x minus 8y square dx plus 4y minus 6xy dy, where C is the boundary of the region bounded by x equal to 0, y equal to 0 and x plus y equal to 1, right? So we are going to verify Green's theorem, and for a given integral is like this. Okay, what is C? C is the boundary of the region defined by x equal to 0, that is y axis, x axis and a straight line, right? Okay, so what is the statement of Green's theorem? Green's theorem states that, write the statement, mathematical form. Integral over C u dx plus v dy equal to double integral over R dou v by dou x minus dou u by dou y into dx dy, right? So what is u here? So this so we are going to prove LHS equal to RHS, right? So before that, what is u, what is v? Okay, see the question here, right? So here integral over C, right? So what is the coefficient of dx here? 3x minus 8y square, that is u. Okay, what is u? U equal to 3x minus 8y square. Similarly, what is v? V is coefficient of dy, 4y minus 6xy. Same thing here, v equal to, just compare this LHS and the given problem, I mean a given integral in the problem. Okay, so u equal to 3x minus 8y square, v equal to 4y minus 6xy, right? So here in Green's theorem we need dou v by dou x and dou u by dou y. So first to find these derivatives, differentiate u with respect to y. If you differentiate this u with respect to y, x is constant. Okay, this become 3x becomes 0. Differentiating 8y square, that is y square become 2y, that is minus 16y. What is dou u by dou y? That is equal to minus 16y, right? Okay, what is v now? V equal to 4y minus 6xy. Now differentiate this with respect to x. So if you differentiate with respect to x, the y term becomes 0. Okay, this become x become 1, so we have minus y. So first to find the function u and v, and the partial derivatives dou u by dou y and dou v by dou x. Okay, is the very first step in Green's theorem. Now we are going to prove LHS is equal to RHS, right? So first we are going to find LHS. So what is LHS here? Integral over C u dx v dy. Before that we should know what is curve C. Curve C is the boundary of the region. Curve C is the boundary of the region bounded by x equal to 0, y equal to 0 and x plus y equal to 1, right? Okay, just like this, see the diagram here. So here x equal to 0 is this one, y equal to 0 is simply x axis, this is y equal to 0. So and this is x equal to 1 minus y, or x plus y equal to 1, that is a straight line. Okay, so if you put x equal to 0, Simply if you put x equal to 0, y becomes 1. So the point is 0 comma 1. If you put y equal to 0, then x equal to 1. Join the points, we get a straight line, right? So what is x equal to 0? This axis, x equal to y axis. Y equal to 0 is this axis, that is the x axis. So the line x plus y equal to 1 is the straight line. Okay, draw this straight line. Okay, right. Now the point 1 comma 0 is a here, the point 0 comma 1 is o here, the origin is 0 comma 0. Okay, now put direction lines oa, ab, bo, right? oa, ab, bo is the closed curve. Okay, what is c here? The c is the path here, actually closed path from o to a to b, b to a, right? So we can write like this: integral over c u dx plus v dy is oa, ab, bo, like this: oa, ab, bo. Okay, right? So we have to evaluate this integral for oa, ob, bo, then add all the integrals. Okay, so first we are going to find along oa. So oa means, what is the equation of oa? This is OA. Equation of this x-axis. So y equal to 0. So its equation is y equal to 0. Differentiate this, become dy equal to 0. Okay. Now integral over OA, write the equation, the given problem, right? This thing. This is the given problem, integral. Okay. Write this thing, put y equal to 0 here and dy equal to 0. What happened? If you put y equal to 0, this term becomes 0. Okay, we have 3x dx, 3x dx. If you put y equal to 0, dy equal to 0, the entire term will become 0. So we have simply 0 to 1, 3x dx, right? Now we should find what is the limit here. Okay, so here OA, now see here, OA is the line here, right? What is the value of, we need x value only, right? We need actually x value, dx means we need x limit, right? So what is the point here? X 0 to 1 here. There is no change in y. See y. There is no change in y. Therefore, the limit is 0 to 1. Okay. Right? 0 to 1. Now integrate this. If you integrate this, we get 3x square by 2. Actually 3x square by 2 this. You see. This is equal to 3x square by 2. See here. 3x square by 2. Now apply the limit. Become 1 by 2, that is 3 by 2. So along OA, this is 3 by 2. This step is actually here. This statement is wrong here. If you integrate 3x, become 3x square by 2. Okay, right. Next, along AB. So what is AB here? See, this is a straight line AB. Okay, this is straight line AB. Right. So what is the equation? Equation of this is x plus y equal to 1. So what is y? Therefore, y equal to 1 minus x. Differentiate this, become dy equal to, this becomes 0 minus 1. Therefore dy by dx equal to actually minus 1, dy equal to minus dx. Okay, right. Now so integral over second curve here is AB, integral along AB, right? AB. Okay, so here we have two variables, x and y. We have only single integral, so we should convert the entire thing into one variable, either in terms of x or in terms of y. So we are going to use in terms of x. Okay, so what is y here? Y equal to 1 minus x. Put here y equal to 1 minus x. 1 minus x the whole square, actually, right? The dy equal to minus dx. Dy equal to minus dx, right? 3x minus, then apply a minus b whole square formula, 1 plus x square minus 2x. Okay, after simplification we get this step. Actually here also 1 minus x the whole square, right? Similarly, simplify the expression. Okay, here we have 2 dx, take 1 dx as common. Okay, simplify, simplify the expression. So we have one variable. Okay, one variable here, right? So what is the limit of x now? AB, the direction is AB, direction is very important, a to b. So what is the value of x here? 1 to 0. It is completely reverse direction. Okay, 1 to 0. Now integrate this with respect to x, then apply the limit. Okay, if you simplify this expression, we get 13 by 6. Okay, right. Now Last one is along BO. What is BO here? This direction, B to O, B to O. Okay, what is its equation? Equation x equal to 0, right? X equal to 0. Therefore, differentiating this dx equal to 0. Similarly, substitute here. If you put x equal to 0, dx equal to the entire term becomes 0. If you put x equal to 0, this term becomes 0. We have only 4y dy. Okay. So, what is the limit of y here? So, y is in this BO. Okay. 1 to 0. See the direction. That is very important. So, 1 to 0. 1 to 0. 1 to 0. Now, integrating this y square by 2. Okay, after simplification we get minus 2. Hence, what is integral over C? U dx plus V dy equal to add all the results. We get 5 by 3. Right now we are going to prove RHS. What is RHS here? Double integral over R dou V by dou x minus dou U by dou y dx dy. What is dV? dV by dx? See here, dV by dx equal to minus xy dou u by dou y equal to minus 16y. Okay, right? So substitute here both the values, right? After simplification we get 10y dx dy, right? So we don't know the limits. What is the value of x, x limit and y limit? We have two variables, so we are going to draw a strip here. This is the region. We have double integral, so draw the region like this, right? We have dx dy order. Okay, we should draw horizontal strip like this. The strip begins from x equal to 0, end at x equal to 1 minus y. Okay, x equal to 1 minus y, right? Or x minus y. We can choose any order, but here in this problem we are choosing dx dy. You can choose our dy dx also, right? So if you choose like this dx dy, so what is the limit of x here? Limit of x is 0 to 1 minus 6. Put here 0 to 1 minus 6. What is the limit of y here? For this you have to choose the axis limit, right? So what is the limit here? For this 0 to 1. Y limit is 0 to 1. We put y equal to 0 to 1 here. After integration, after simplification, we get y into 1 minus y dy, right? Again integrate this with respect to dy, and after simplification we get 5 by 3. So already in our LHS is, right, in your LHS we have 5 by 3. This time in our RHS also 5 by 3. That means LHS equal to RHS, hence Green's theorem is verified, right? Thank you.